Hello and welcome to the Tawaki Project headquarters here in Dunedin. My name is Thomas and today I'm going to try something new. A YouTubeified version of a presentation I gave to the Birds New Zealand South Otago branch. It tells the story about how the Tawaki Project came to be and summarizes what we've done so far. This is the first time I'm doing something like this and I really hope I don't come across like a big dork. But most importantly, I hope that you enjoy this kind of content. And if you reach the end of this video, maybe you feel inclined to help us to continue our work with New Zealand penguins and bring you more stuff like this. So without further ado, let me introduce you to the Tawaki Project. Did you know that New Zealand hosts 1/3 of the world's penguin species, 6 out of 18? Of these 6, 3 live and breed on the mainland. That is the Fiordland penguin, the yellow-eyed penguin and the little blue penguin. And as mainland birds, of course they also have Maori names. Tawaki, Hoiho and Korora. Now the interesting thing about these Maori names is that both Hoiho and Korora are what linguists call an
Onomatopoeia.
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 Right, gotcha. Onomatopoeia, that is, names that resemble the calls of the birds. But that doesn't apply to Tawaki. Fiordland penguins are most likely named after a demigod from Maori mythology, a guy called Tawaki that roamed the earth in a human disguise. One day when he thought nobody was watching, he threw away his vile garments and clothed himself in lightning. And you don't have to stretch your imagination to see a crown of lightning in the Fiordland penguin's yellow crest. But what else do we know about Tawaki? That is, the penguin, not the god. Well, we know where they breed. If we take the southernmost largest settlement on the South Island's west coast, Haast, as a reference point, it becomes apparent that Tawaki like to stay away from humans. They populate mainly the remote coastlines of Southwestland, Fiordland and Stewart Island and its outliers. These yellow blobs represent known and surveyed breeding locations of Tawaki. The size of the blobs indicate the relative number of penguins at these sites. So, how many are there? The current estimate puts the total number of Tawaki somewhere between 5,500 and 7,000 breeding pairs, which makes them the third rarest penguin species behind the Galapagos and the yellow-eyed penguin. But there's a slight problem. We're actually not quite sure whether these estimates are actually correct. Let me show you why. Let's take a quick tour to Breaksea Island on the southern fringes of Fiordland in a hotspot for the penguins. To survey Tawaki, you first need to survive landing there. And once you made it to the island, you have to find them. That is no mean feat. In this image we have a penguin. Let's call him Waldo. If you see him, well done. And if not, let me give you a hint. And if you think this habitat makes counting penguins kinda difficult, let me take you to Stewart Island, or more precisely the northeast coastline of the island. In the early 1990s, a comprehensive survey of Tawaki concluded that there were no breeding pairs on the northeast coast of Stewart Island. So the official figure for that area is 0, zilch, nada. However, 10 years ago when we were working with yellow-eyed penguins on Stewart Island, we would use sea kayaks to get to our different study sites. And we would almost always encounter Tawaki on our paddling trips, and not just 1 or 2. No, but many birds, up to 60 penguins we spotted foraging in a big group. That seemed rather strange given that they weren't supposed to be there at all, officially. In 2014, I had the chance to survey some of the northern Stewart Island coastline, and at low tide I came across a hole in the rocky foreshore, from which muffled Tawaki calls drifted to my ears. It was a narrow cave, the ceiling of its entrance dangling with seaweed. And after climbing into the narrow tunnel, I heard shuffling of tiny feet ahead of me. And then, about 10 meters in or so, I saw them. Little black and white cavemen. Tawaki. And they had chicks with them. I had just discovered a small Tawaki breeding colony inside a sea cave. A sea cave whose entrance is completely submerged in high tide. You have to dive in to see the penguins. These two examples probably demonstrate quite well why I'm tiptoeing around making the official Tawaki population estimates sound as if they were set in stone, because they're not. Yet the species is believed to be undergoing a decline, and this is based on observations that were mainly made at one site. Whether this assumption is true remains unclear, but any indication of a decline is bad. And if we're talking about potential declines, we also have to talk about threats. Let's take a look at threats on land. There are the usual suspects: stoats, rats, dogs, possum, weka and cats. Although, hang on, while weka may prey on Tawaki eggs and chicks, they have done so for millennia, so the penguins should know how to handle them. Which means that weka being responsible for a Tawaki population decline seems unlikely. All the other are exotic predators introduced by humans, and of those, stoats and dogs are probably the biggest threat to Tawaki. Although there are other land-based threats such as humans that care more about cool selfies than the dignity of a wild animal. Yet even well-meaning people that just want to enjoy watching the penguins can represent a problem. Tawaki are a timid species, perhaps as a result of centuries of hunting by Maori, and just sitting in clear view of a Tawaki may stress the bird out even though it might not be able to show it through its behavior. So it's better to stay out of sight. But Tawaki are marine animals that spend a huge amount of their time out at sea. And while it may be hard for us to imagine what happens below the ocean's surface, there are some threats in the water for Tawaki, some of which flash an impressive set of teeth. Leopard seals, sharks, and sea lions or fur seals are all known to enjoy a snack of penguin every now and then. But we have to keep in mind they're natural predators, and they are not really news for the penguins. Tawaki had to deal with them since ages. But in the past 100 years, dark clouds started gathering over the Tawaki's marine habitat. Climate change and ocean warming can negatively influence primary production in the ocean and subsequently affect the prey of the penguins. Fisheries interactions may pose a significant threat, especially accidental entanglement and drowning in set nets, or gill nets as they are called. And then pollution could become a real issue for Tawaki if New Zealand's plans for deep-sea oil exploration along the west coast were to become a reality. All these threats are man-made threats, but unlike climate change, which can only be tackled by all the nations on this planet, fisheries and pollution can be managed on a regional scale. But to know what could be or is bad for Tawaki out in the ocean, we need to know where the birds go and what they do out there. And this is where the Tawaki Project comes in. But let us start at the beginning. This is a younger version of me doing fieldwork for my PhD on snares penguins in the early 2000s. And this is Ursula Ellenberg, who also did some of her PhD research on the same species. And here we have Dave Houston. In case you were wondering, it's this guy up here, who is the penguin expert within the ranks of New Zealand's Department of Conservation. And as fate would have it, the three of us are still working together in the Tawaki Project. But let's go back to the snares for a moment. Our main focus was to study the snares penguins' foraging movement and diving behavior, and we used cutting-edge GPS dive loggers that had just come out. The data we collected was super fascinating, as the penguins were doing exactly the opposite of what we thought they would do. Instead of swimming towards colder waters to the south of the island we thought were more productive, the snares penguins foraged to the north, closer to Stewart Island, and closer to Tawaki. And since the Department of Conservation was also interested in the foraging ecology of Fiordland penguins, the idea was born to integrate Tawaki into my PhD. In September 2003, I did a recce trip to Breaksea Island in Fiordland together with my supervisor Lloyd Davis and Ursula. Luckily, we took a helicopter and not a boat, so I was confident that we'd survive the landing on the island. Or so I thought until we hit an air pocket and plummeted down towards Doubtful Sound, which wasn't nice at all. But anyhow, we eventually reached Breaksea Island, alive. For 3 days we climbed through the jungle on the lookout for Tawaki. The terrain was pretty steep and scary at times, but I think I had myself a bit better under control than Lloyd apparently did. And here on Breaksea Island I took my first ever photo of a Tawaki. And I was determined to find out more about the species. But alas, I was already halfway through my PhD, and on top of that we had issues with getting permits, so I had to ditch the idea. So after I finished my PhD, I thought it would be a fantastic idea to do a postdoc on this species. Of course, that was back in the days when New Zealand still had postdoc funding. But despite submitting 2, in my opinion, really good applications, they were unsuccessful. So, sadly, Tawaki slipped out of focus. Until 2011. That year, Ursula was tasked to test the disturbance effect and the efficiency of DOC's Tawaki monitoring program on the west coast. It wasn't quite what I had in mind during my PhD, but it got us back in touch with Tawaki. And it resulted in the first scientific publication on the species in 15 years. But it was the year 2013 which brought the turn of the tide for our research endeavors. At the International Penguin Conference in Bristol, we sat down with Poppy Garcia-Boberoglu, president of the Global Penguin Society, and Helen Otley, who had just come over from the Falklands to work in New Zealand for the Department of Conservation. Both were keen to help us get a proper Tawaki study off the ground, and Poppy came up with a plan to kickstart what would become the Tawaki Project, a long-term study to learn more about one of the rarest penguin species on this planet. So, here we are, 2017, with 3 years worth of fieldwork already under wraps. And we've accomplished a lot. Let me tell you about it by going back to one of the few things we knew before the project started: where Tawaki live and breed. As I mentioned earlier, Tawaki live and breed along the southwest coastlines of New Zealand's South Island. This breeding range can be divided into 3 core regions: West Coast, Fiordland and the Foveaux Strait Islands. To understand that this is not arbitrary zoning, we need to look at the ocean properties of these 3 regions. Along the west coast, the ocean is dominated by continental shelf, that is between 100 and 1000 meters deep. In contrast, there's no continental shelf to speak of in Fiordland. So if penguins breeding here forage outside the fjords, they are in 2000 meter deep and deeper waters, a truly pelagic environment. Foveaux Strait is the exact opposite, with water that's hardly exceeding 20 to 40 meters, very shallow coastal marine habitat. Now this throws open the question how these differences in the marine habitat reflect in the penguins' foraging strategies. Being able to adjust behavior to such different marine habitats is probably an indication for quite a bit of flexibility in what they do. This may render Tawaki well adapted to variability in the environment and more resilient to climate change compared to other penguins. Of course, in order to understand such differences, working at only one site won't cut the mustard. Instead, we need to study penguins breeding in those different habitats simultaneously. So the Tawaki Project works at 3 sites: Jackson Head on the west coast, Milford Sound in Fiordland, and Codfish Island down in the Foveaux Strait. To study the penguins at sea behavior, we used GPF dive loggers similar to the ones we had successfully used on the SNEERs 10 years earlier. The main difference is that these devices are a lot smaller now, which is something the birds certainly appreciate. The Tawaki Project started off with the pilot study at Jackson Head in 2014. The first year was more about getting to know the environment as well as the birds, and to see how the penguins tolerate our interactions with them. Over the course of 4 weeks, we managed to deploy GPS loggers on 4 birds. We were able to reconstruct 9 foraging trips from the data they returned. And for an offshore forager, the birds seemed to stay remarkably close to the shore. While the chicks were still small, the penguins would stay in a 12-kilometer radius from Jackson Head. Only when the chicks were bigger and could go for a few days without food, the adult penguins would leave the colony for a day and a half, or maybe 2 days, and then they traveled up to 60 kilometers away from their nest site. In the following year, we returned to Jackson Head with the plans for more deployments, but nature had its own ideas, and we only got data for 6 birds. Nevertheless, these data told a clear story. While the chicks were still small and needed to be fed every day, the penguins traveled vast distances. As a result, chicks were fed only every second day, if they were lucky. So, what gives? Let's have a look at the ocean productivity during those 2 years. In 2014, the waters immediately off the west coast were very productive, as indicated by the yellow and red colors. And if we zoom in, we can see that the penguins foraged in those productive areas, reasonably close to home and within a neat and yellow-red band of productivity concentrated along the coast. Now let's fast forward to 2015. Quite clearly the ocean productivity wasn't as high that year. Less yellow and very little red along the west coast. Zooming in shows how this affected the birds. Ocean productivity was not only lower, but also much further distributed from the coast. As a result, the penguins had to travel much larger distances to find pockets with increased productivity. If we compare the data from both years side by side, it's apparent that during the year with higher productivity, the penguins managed to find food within a much smaller area than in 2015. But why was that?
The answer, my friend, is a blowing in the wind.
Thanks, Bob. You're certainly onto something here. This is what the general wind situation was like in September 2014. Winds coming from the northwest, pushing the surface waters of the Tasman Sea across to New Zealand. And with it come nutrients and trace elements, blown in as dust from the Australian outback and carried across to New Zealand, piling up on the west coast. Also piling up are clouds along the western ranges of the Southern Alps, resulting in considerable rainfall so that even more nutrients are flushed into the ocean through the west coast rivers. All these nutrients are stirred into the near coast shelf region, resulting in a concentrated band of high productivity. Let's fast forward again to 2015, when one of the strongest El Niños in recorded history occurred. If you have no idea what the climate phenomenon El Niño is about, I recommend getting it explained by Hank Green over at SciShow. During El Niños, the wind patterns over the Tasman Sea are often reversed, meaning that the wind blows principally from the south and thus acts as an antagonistic force to the transport of Australian nutrients across to New Zealand. At the same time, the west coast experienced lower than usual rainfall, so that there's less nutrient influx from that side as well. In other words, there's nothing to fuel ocean productivity. Quite clearly, El Niño is bad for Tawaki. Or is it? In 2015, we also worked for the first time in Milford Sound. Here we managed to track penguins with the fantastic support of the people from Southern Discoveries. We deployed devices on penguins breeding in Harrison Cove, about 9 kilometers from the open ocean. And the data we got back was not at all what we expected. To cut a long story short, the penguins basically hopped in the water and started foraging. No traveling 50 or more kilometers, no staying away for several days. Instead, the penguins basically left their nest at first light, stayed within 3 kilometers from their colonies before coming back to feed their chicks in the evening. That this was unexpected to us is a bit of an understatement. Not only did no penguin really leave the fjord, they hardly even utilized the total area available to them within Milford Sound. Instead, the penguins preferred to stay in Harrison Cove all day. And to give you a sense of scale, let's zoom out and compare the foraging ranges at Jackson Head and Milford Sound. In case you missed it, Milford Sound is down here. And these differences also reflected what was happening on land. At Jackson Head, most of the chicks died of starvation. In contrast, in Milford Sound, breeding success was phenomenal. Obviously, El Niño does not affect Tawaki in the same way across the entire breeding range. Clearly, for this species, we have to step away from a one-size-fits-all conservation strategy. Now, let's take a quick breather here, because there is so much more that we've achieved with the Tawaki Project so far. Okay, ready for more? Right, let's crank it up a notch before this video gets any longer than it already is. Number 1. Last season, we also managed to track Tawaki on their journey into the Big Blue after they finished breeding. Using satellite tags, we followed their movements towards the subantarctic waters for 8 to 10 weeks before the birds returned to molt. And I'll leave it at that for the time being, because this will certainly make an interesting video in its own right. Number 2. Julie McGinnis from the University of Tasmania is currently sifting through Tawaki poop samples. She's using DNA fragments of penguin prey in the poop to determine what the penguins have eaten. Incredible stuff. Poop, that is. Number 3. Tess Cole from Landcare is also looking at DNA, but this time it's Tawaki DNA. She investigates how Tawaki from different breeding areas relate to each other, and she's trying to put Tawaki in a genetic context to other crested penguin species. And hopefully she manages to show the Australians that Sneers penguins and Tawaki are not a single species. 4. Together with Robin Long, I managed to survey a few Tawaki breeding sites within Milford Sound that have never been checked before. I mean, I don't want to spoil the fun for anyone wanting to read the paper that's going to come out in the June 2017 edition of Notornus. But we found way more birds than are officially on record. Number 5. To date we have nearly 1 million photos of Tawaki nests recorded with time-lapse cameras. We want to analyze these data to get a better idea about nest attendance patterns and the fate of eggs and chicks. Hopefully we can put all these pics up on penguinwatch.org and let you guys help us with the analysis. And not to forget that we're working closely with the West Coast Penguin Trust and their project to determine the impact of terrestrial predators. Without the intention to brag here, the Tawaki Project has achieved a lot in the past 3 years, and all of that without any academic funding. We couldn't have done any of the work without the help of many people and organizations, some of which have nothing to do with research at all. Now, looking at all these logos may make you think that we are swimming in money. Well, we are not. All scientists involved in the research do so in their spare time. None of us receives a salary. Some of us even pay for their own flights to come to work with Tawaki. Can we keep this up much longer? Probably not, but we are going to try. And that's why we are now launching the Tawaki Project on patreon.com. If you don't know what Patreon is, it is a web-based service where people get together and help to financially support creators. Musicians, writers, painters, all kinds of creative people. And if you think about it, that's what we do as well. We write about our findings and create artwork to illustrate our results. Well, we don't think about it, but that's probably for the best. Patreon is probably best described as a subscription service. Supporters, or better patrons, can send us a couple of dollars, $5, or whatever they can afford on a monthly basis. And the more patrons we get, the more we can do for the Tawaki Project. There are rewards for supporters too, so you should definitely go check out our Patreon page. So on behalf of the Tawaki Project, thanks so much for your attention. And please, if you can, go to patreon.com/Tawaki Project and help us to continue our work. This is Thomas, signing off.